the Covenant Labs weekly roundup of what we've been up to. Okay, so what have we been up to this week? It's been a very interesting one. First of all, I'd like to shout out Chris from Masari and also Grant from Ventura Labs. So Chris was kind enough to write about our work this week. It led to a little bit of introspection, which I will come back to in a moment. Okay, so let's start with the roundup. So it's been a very explosive week. Lessons learned, and we're moving on. So let's start with Templar. So in Templar, very good news. We're coming to the post-training of Covenant 72B. It's going well, and we should be getting a final report and the model soon. Now, I like to taper expectations. GLM5, which is SOTA for open weights models, was traded on 28 trillion tokens. We just did 2 trillion for Covenant 72B. We think it's an okay model, but it's not going to be GLM. How do we get to GLM? First off, there's two problems we need to battle: our wall time and our GPU efficiency. And also, how do we just get that much compute? We cannot beat Google by being Google. Apply that to everything. Okay, we want to train big models. If we blindly assume that, okay, they ran with 3,000 B2 300s, so unless we can amass 3,000 B300s, we will fail. We have failed already. We will thrive by scarcity through innovation. And Covenant's already doing that across the board. We have the most performant decentralized training algorithm, both in decentralized post-training and pre-training. Now, how do we take that step further? Things we suffered from in 72B is our MFU, which is how much of the compute we can actually utilize. It was very bad. So how are we solving that? As we prepare for our next run, we are leaning deeper into BitTensor. As opposed to just going to a lab or going behind doors, then pushing out a new algorithm, we're exposing each problem we have across every single facet of the protocol for the miners to solve. So the first problem we're facing is MFU. It stands for model flux utilization. It's a fancy way of saying this is how much the theoretical limit GPU does versus how much we actually observe. Now, shocker, it's never above 70%. You understand? But and I think for Covenant 72B, we had like 30-something%. So in our first thing, we're launching the Crusades where miners compete to fix something. So far, they're doing single GPU on A100s. It's actually quite funny how everything has evolved with that, because anyone that knows BitTensor knows miners can't be trusted. They will cheat. Miners will do everything but what you want them to. But so as a software owner, your job is to force miners to do what you want them to do. When you set up a protocol, they will do everything but what you want them to do. So you have to keep patching things till the only way for them to make money is by doing what you want them to do. And when you get there, it's magical. So across the past week, miners found amazing ways to hack us, like by artificially inflating the wall time, by doing a lot of crazy things. But I think we've settled on a form that doesn't seem to expose as many hacks, and it's doing quite well. I think we're at 66% now. We will leave it running for about a week and possibly try to outmine them, because if no one can do it, then we will try outmining them and burn whatever we get. Again, our intention is not, we get enough from the owner key, but it's to be that force that pushes miners to earn their money. So that's working out well. Then we'll go to multi-GPUs to also optimize that. And everything from that run goes into our next run. So what does our next run look like? So far, what Templar has done is data parallel. Now, while in itself is a step function, no one does it better than us in the world. It's very limiting because each accelerator and each node has to be able to load the full model into its memory. What does this mean? It means that if I'm training a 10B, every single node that wants to participate has to have enough memory to train a 10B. Now, it gets us into a better place, but it limits the amount of compute that can join our cluster. So how do we plan on expanding this compute that's available to our training routes exponentially? It's heterogeneous sparse loco. So it combines learnings from pluralysis and protocol model, in which they do something called the Grassman's, it's some nerd shit here, and a sparse loco, which is SOTA for data parallel, in that we can have clusters of data center compute interweaved with consumer compute. And when we do this, we expect the amount of compute we can leverage without breaking the bank. Because again, without breaking the bank to grow up tenfold. And then we can train a model. So there's a couple of challenges to this. That, okay, when you get this thing working, how do you drive efficiency towards it? Because one thing we also learned is we're in a very interesting space where in this current form, the amount of the model size we can train is bound by the token price, which is bound with the tau price. So the more volunteer compute we can leverage effectively, the clusters can grow. So all I could think about is the internet is the data center. And once we can fully unlock this, that's the next goal for Covenant. So that's what we're going to be working on. So to reiterate, Templar, very good. Miners, cheeky fuckers, but also helped strengthen the protocol. We hope to be moving to multi-GPU sometime next week. Next, we have Grail. So Grail is doing well, and Erfan absolutely killed it at Yannic's meetup. So people that don't know what Yannic's reading group is, it is one of the most OG ML reading groups there is in the world, and it's not just crypto specific. Now, for us, ML people to AI people do not fuck with crypto, and I don't blame them. Like, I really, really don't blame them. So it just makes it harder for people like us that, need that credibility, people that are doing like actual good work to be seen. So we were actually quite impressed that they allowed us on. And honestly, you can go check the channels. He got a standing ovation. Erfan absolutely killed it. So what does it work from Grail do? I think it can, in some space that Erfan's finding. Okay, you can't compare push training and pre-training because the pre-training guys always argue that push training is a lot easier. But what he means is with Templar, we are trying to converge with centralized speed because there's only one process. But in push training, there's two processes. You generate the inference for the rollouts, then you train. With Grail, we decentralize the inference workers and not the trainers. But there's still this communication cost we pay because when you finish training, you have to update the base model. You have to transfer the weights. The work Erfan found out and uncovered means that we are pretty close to training in a data center. That's fucking mind-blowing. They were like, it was very well received. So what are we doing from now? We want to train. The crazy thing is we're closer to training a good model on Grail than we are on Templar. Because with Templar, there's a caveat. We don't decentralize the trainer, but if we did decentralize the trainer, then Grail becomes a massive headache. With Templar, everything is training. So that is the process. It's hard work. It's a lot of hard work, but it's also very valuable work. So our next stop with Grail is we're going to attempt to train a useful model for kernels via RL. So, if anyone can achieve SOTA on kernel development for agentic kernel development, I think it's Erfan. He has my full blessing. So that's where we're going. That's where we're going now. Now, next, Basilica. So Basilica is also being very interesting. We're at a point where we've built one of the most expressive compute platforms. So it's very, very easy for us to spin up new applications, for us to host like multi-tenanted. We can literally do anything. So last week, I'm in a group with Mark Jeffrey, and he would not shut up about multibots. All he fucking talks about is multibot. So he goes, hey, Sam, we should have this. And so before OpenClaw really kicked off, we had already had a CLI tool for people to deploy this very quickly. Now, that showed me a very, very interesting lasp in both understanding the customer and product development. Why? So the problem with OpenClaw, one of the problems, it's not very good software, but I digress. One of the problems with OpenClaw, it is very hard to develop. But if Basilica's form factor is just a CLI, then people that use that CLI, they don't care. Like, they will just go through the pain. It's not that big of a pain enough for them. But there's also massive pain. There's a lot of people that don't want to be left out in the agentic development world. So what did we do? we spun up a UI. And lo and behold, it has been on fire. Honestly, like I can't, it took me like an hour to vibe code that stuff. The uptake has been very, very impressive. But it also showed me I learned a very bitter lesson. Because you can vibe code something in an hour doesn't mean it's ready to be released in an hour. So mea culpa, first of all, OpenClaw itself, it's very brittle. And there were a lot of things we missed. And it just made supporting it hell and the user experience not that well. But we will fix it. Then we will go to market properly with it. Because when I was building this, I realized that we have like 100 people using this thing right now, paying for it, paying to use it because it's very easy to spin up. Now, once we push out all the bugs, we start a proper go-to-market push because here's the vision for what we want to build. Most of the people that use it, what are they using it for? They're using it to mine. These are people that think, okay, wow, we're dropping the veil. What's the first thing they want to do? It's mine. So I started thinking, okay, what if you guys had OpenClaw, one click, you get an OpenClaw instance that understands BitTensor, that exposes the APIs from other subnets directly to you. I think that's a very powerful primitive because first, it helps people build subnets because it understands BitTensor. It's connected to the TauStats API because we integrate their APIs. And so it led to me building what I hope will be a universal NCP server for BitTensor. We will host it. We're adding a couple of subnets to start off with and just create this massive sink for BitTensor products. We know what subnets are shit. We know what subnets people don't want to pay for or whatever. So that would be pretty interesting. I don't want to push that out. The code is ready, but one thing I've learned, because you can write it in 10 minutes doesn't mean you can push it in 10 minutes. Otherwise, you're going to spend a week with angry customers. So we've learned from that. We've moved on. Yeah, so that's what it is. We have another interesting update we have on Basilica. One of the big subnets built a product. They're going to integrate into Basilica natively. Gradients have, oh my God, I cannot thank Gradients enough for using Basilica. They're currently using it free because we gave them a lot of credits, but I would have given them 5 times the amount of credit due to them hammering our protocol. Like, because again, when you test it, you test for a certain use case or your narrow thing. These guys are spinning up 100 pods at a time. They're shutting them down. You get random race condition. So that is very interesting. We have 3 more subnets that we're going to onboard, and another subnet is going to integrate. They built an amazing product that's going to natively integrate Basilica so they can deploy stuff directly to it. So initially we built Basilica. We fucked it up so much, but I think this time we're ready. We're ready. Now, another thing to understand is there's still ongoing work with fully rolling out our incentive mechanism because with Basilica, we can decouple the application from the actual incentive protocol because we do use centralized compute. The aim is to push miners to supply performant and secure compute and supply it cheaper. So the new consensus mechanism is out. It's becoming a market force that procures cheaper compute. Because if you look at things now, most of the time you can't even find H200s. And this is something we think we can approach the miner, say, okay, do we need to give you guys to get us H200s? And if we have H200s, how can we make money on it? So it's a very, very interesting time. Cool. And lastly, I'll touch on what Chris's article made me think. It says permissionless AI lab, yeah? But that's not the mission. The mission is to the weight to the mission. But what are we trying to achieve here? We're trying to make sure that the narrative is nihilism. Everyone is worried about the perpetual underclass. So what are we doing to get there? Is race towards it, be part of that system or be part of the perpetual underclass. But what makes you part of that perpetual underclass is that eventually all of us, we fear that we will not be able to survive in a world where we don't own these models. We cannot access these models. So right now, inference is too cheap. But I work in the trenches, and up to 90% by some estimate of the world's compute is going to be inference. So for me, I see Covenant Labs as a counterweight to nihilism. We will make sure that the future AI is always accessible by way of leveraging the long tail of compute. That's what it is. So how are we doing this in Templar and Grail? We're saying the internet is a data center. Once there's a GPU with a broadband connection, we will train on you. And eventually we might do inference too, who knows? I do have code for it, but we're just doing too much. On Basilica, it is how do we source this compute? How do we aggregate them? How do we take untrusted compute and make it work and make it performant? So that is what the mission is. I'm pretty excited to be working on this. I think for me, it's probably the most important work I'll ever do in my life. So very happy for everyone to be joining us. One more announcement. Next week, I will be in Nairobi. I'll be talking at SoundCloud. I'll be outpilling some of the people there. I'm very excited about the test in Africa. I'm from Africa and I'm from Nigeria. And I strongly believe innovation occurs at the edge. The edge is where scarcity is. The edge is where you don't have a choice. And if you look at some remarkable cases, modern mobile payments came from Kenya. eSIMs came from South Africa. So I'm pretty excited about that. If anyone's around there, give me a shout. Cool. Okay, that's it for this week. Chris, thank you very much for joining us. Have a lovely weekend, guys. Bye.